today we cover the last section for chapter differentiation, which is engineering application. Okay, so as we know that we use most differentiation and also integration in our engineering application, and more we use to find let's say example for tangent and normal lines of curve. So where we can find the slope, and also we can find the differentiation uh, of the line or of the curve, let's say by given by y equal to fx, and we can find the differentiation at any point, let's say point P, and the line PQ where is actually the normal curve. So how it's look like, it will be like this lah. Okay, we have x and y axis. Okay, so then let's say this is the curve, the red color, where it's actually y equal to fx. So this is the curve. And then we put a tangent line here on the top of the curve here. Then there will be a normal line which is perpendicular to the tangent, which is 90 degree. So PQ is the line which is a normal line, which is perpendicular to the tangent at the top of this curve. So we can find the differentiation of curve, and then by using from the point slope formula, we can find the formula of the tangent line, which is the blue color tangent line here, of a curve at the given point, which is y equal to y naught, y at 0, equal to f prime, which is the differentiation of function or line curve, x naught times by x minus x naught. So the normal line is the line that is the perpendicular to the tangent of line of curve, and the formula for the normal lines, which is y equal to y naught equal to y minus y naught equal to 1 over f prime x naught times by x minus x naught. So we also can recall back that to find the slope of the perpendicular, okay, to find the slope of the perpendicular, we can find by using this formula, where m1, m2 equal to -1, where m1 is for normal and m2 is for slope tangent. So this one is for tangent line, and this one is for normal line. This is normal, this is tangent. Okay, then some example. Given a function with a curve defined by, this is the equation, the curve, which is y equal to 2x cubed plus 3x squared minus 2x minus 3, and point p x equal to 1 and y equal to 0. So from here, you can differentiate this equation y. You can differentiate, so you will get 6x squared plus 6x minus 2 here. So when you differentiate this equation, okay, this is actually the slope, and you input the x equal to 1 and y equal to 0. So you will get x, when x equal to 1, then you will get the slope dy dx is equal to 0. So your slope here is actually equal to y equal to 0. If you remember that the normal line, we should have normal equation. y equal to m x, right? Let's see. Okay, and then so here is m lah actually, which is dy dx is actually the slope. Okay, dy dx is the slope from this equation. So the slope value is 10. So now we can use the tangent line equation, and also you also can use after that the normal line equation formula, which is this one lah, dimasukkan ke dalam. This is formula for tangent line, and this is formula for normal lines. Okay, so let's you insert into the normal tangent line formula. Y equal to y naught y minus y naught equal to slope, which is dy dx, x minus x naught. So as we know that y is y, but y naught is 0, you put 0 here. Dy dx, the slope is actually 10, and x is given here, x is x, and x naught is 1. So then you restructure back the equation, you will get y equal to 10x minus 10. So this is the equation for tangent line. Okay. So the equation for tangent line, right? Y equal to mx plus c. So after you find this equation for tangent line, then you can find the normal slope. Okay. So this slope is for tangent. Okay, as the equation is f prime kan, equation dia bagi f prime tadi kan. So now we will need to find the normal slope for you can find the normal slope by using this formula, which is m1 times m2 equal to -1. So m1 is actually slope for normal, and m2 is for tangent. So this is m2 for tangent, m1 for normal. So mana yang dah ada? Yang dah ada tangent kan? Tangent adalah 10. So now m1 times 10 equal to -1. So you susun balik, and you will get m1 equal to -1 over m2. So actually m2 is tangent 10. So m1 is equal to -1 over 10, right? So then after you get the slope for normal, now you can use the normal line formula. So you use the normal line formula or equation. So where you can get, this is the normal line equation or formula. Then you have y naught as mentioned earlier, the at p point where x equal to 1 and y equal to 0. So now y is y naught is 0. So here m here, slope here is normal slope, which is -1 over 10. X is x, and x1 is 1. Then you arrange back the equation, you will get 10y equal to -x plus 1. Okay, so this is your normal. So this is your normal line equation. So normal line equation. Okay, so first find the slope. Slope is dy over dx. Okay, dy over dx. Then second, you use the tangent line formula or equation. Then number three, you find the m1 by using the formula. Okay, this is the slope, same m2. And number four, you use the equation of normal line formula. Okay, so this is when we want to find the, let's say in the graph, there are some equation, some line curve like that. So you want to find the normal or tangent line. So normal point here, and also this one will be normal. So ni ada normal, ni adalah tangent. So ni adalah curve, is y equal to fx. Okay, so here's some application for tangent and normal line. Okay, where you can use differentiation. Okay, differentiation here, differentiation to find the slope. To find the slope. All right, and we go back to the normal line equation, as we know that moment at y equal to m x plus c. Okay, m here is actually the slope. Okay, slope, and it can be found by using the f prime or dy over dx. Okay, all right. So that is some example where we can find where we can use differentiation in solving the curve in certain equation that given to you. So let me go for another example. So let's say you need to find the equation of tangent and also the normal to curve y equal to x squared x cubed plus 2x plus 1 at point 1, 4. So now you have, so you may try solve actually, even though there are also answer there, but you can try. Okay, so you have this information. So it asks you to find the tangent and also the normal equation. So you can find by using the step that I show you first before this. So first step, find this dy dx and then insert into normal a tangent line equation or formula. Then find the m1, which is normal for slope. Then you find the normal line equation or formula. So as you can see, when you differentiate the equation of this curve, which is line, you will get 3x squared plus 2. Then you insert the value of x and y directly into the equation. So you only use x, right? So 3 times 1 squared, you will get 3 plus 2, you will get 5. So 5 is actually the slope lah. Okay. And also is m2. Now find using the equation tangent, you will get y equal to 5x plus c through 0.14. So can you solve? What are the value of c? when you insert y and x, you will get value of c equal to 5 times by 1, 5 minus 4. So you will get c negative 1. Right? Okay. So when the equation of tangent given by this, then you will get c, where c is equal to negative 1. Then the required equation of the tangent, you will get y equal to 5x minus 1. Okay, Ken? So now what's next? Try to find the slope for the normal by using the formula m1, m2 equal to negative 1. Okay, kenapa kita guna this equation? So why we use this equation? Because it is y equal to mx plus c. Because when you differentiate here, you only get the when you insert into the normal equation, the tangent equation, line equation, you need to find the value of c. Okay, compare yang tadi tu, dia memang dah ada nilai. The value of normal, nombor bulat. So now we put c here, then you need to find the value of c through the point of 1, 4. Okay. So next, after you find this equation, then you can find the tangent, the correct tangent equation line is this one. Now find the gradient. After you using this equation, you will get the slope of the normal is negative 1 over 5. So insert into normal line formula tadi. So directly is very simple kan. Directly you will get same also here. You need to find the value of c. So when y is 4 and x is 1, then you will get c is equal to 21 over 5. So your normal equation, how is it like? The normal equation dalam bentuk pecahan. So your equation will be in fraction equation, where you will get negative 1 over 5. This is your slope, right? X plus this value 21 over 5. So this is your normal equation for the line of the given curve y equal to x cubed plus 2x plus 1 at point 1 of 1, 4. So this is your answer. Okay. So that is the first one, which is the differentiation can be used normally in tangent and normal line equation. Okay. Next, intermediate indeterminate form and also L'Hopital's rule. So the L'Hopital's rule is a very good method for computing limits if you have an determinate form example. So suppose that 0 over 0 and infinite over infinity, 0 or infinity, negative infinity. So let's say the equation for the function f a over g, function g a equal to 0, 0, or it can be also infinite number, okay, infinity here. So the limit of a ratio of a function approach an indeterminate form. So let's say limit fx over gx where x approach c. So it can be written in differentiation form with limit f prime x over g prime x, x approaching 0. So this is in the form of differentiation part. Okay. If what you end up with has a non-zero denominator, then you can divide out the quotient and produce a limit. If the denominators end up with 0, so if the denominator is end up with 0, but the numerator end up with non-zero, then the quotient has no limit. Contoh 1 over kosong. If you apply the rules once and both numerator and denominator are still 0, okay, simply apply it again until you end up with a quotient that has either the numerator or numerator or denominator both not equal to 0. So let's say kalau you guna rules tadi ni, okay, let's say you use this rule, okay, you need to simply apply again this rule until you end up both or once not equal to 0. Contoh, bila you try first, you dapat 0, 0. Dan you differentiate lagi, you dapat 0, 0. Then you differentiate lagi, you dapat 1, 0. Ataupun you dapat 1, 1. So end up with non-zero, not equal to 0. Okay, either here this one or this one. So this one, kalau dia masih 0, 0, you kena apply again. Apply this, apa nama? Differentiation into the limit. Okay, alright. Example, use L'Hopital's rule, okay, by using the L'Hopital's rule, okay, to compute this function, this limit. Okay. So now you give to you this limit and you use this L'Hopital's rule. So limit sine x minus x over x power of 3 where x approaching 0. So if you simplify, masukkan 0 dekat sini, so you will get both numerator and denominator tend to 0 as x tend to 0 approaching 0 here. So now kalau you simplify masuk 0 kat sini pun dia adalah 0, 0 lah. You will get 0, 0. Okay, now you need to apply. Now you need to apply the L'Hopital's rules. So applying L'Hopital's rules means you need to differentiate this function and differentiate this function. Okay, ataupun Gx lah, G prime. Okay, so sin x, differentiate sin x minus x. Here, differentiation first. Then you differentiate x power of 3. So x power of 3 simple, you will get 3x squared. Sin x, you differentiate, you will get cos x. X, you differentiate, you will get negative 1. 1 lah. Okay. So you simplify, then again masukkan nilai x equal to 0. So you when put x equal to 0, x equal to 0, you still get 0, 0. So kalau you masuk kat dalam equation ni pun, you dapat 0, 0. So what's you need to do? Apply again L'Hopital's rule ni, apply again the differentiation into this equation. You kena buat lagi sekali, differentiate sekali lagi yang equation cos x minus 1 over 3x squared. Okay, that's what it means lah, because you end up with 0, 0. So apply again to this equation cos x minus 1, 3x squared. So you differentiate this, you will get what you will get. Sin x minus 0, 6x, right? Okay, so you differentiate that equation, so you will get the cos x, you will get negative sin x. Then you differentiate the 3x squared, you will get 6x. Then you simplify, masuk balik the x equal to 0, x equal to 0. Okay, then you will get, okay, so then you will get, okay, then when you get this negative sin x divided by 6x, okay, then you will get negative 1 over 6, where the limit x equal to 0, you will get sin x over, you susun balik, and you will get negative 1 over 6 when x approaching 0. Okay, so that you will not end up with 0, 0. So there will be your L'Hopital's rules, then you will get this answer. Another example also, by using the L'Hopital's rule, this limit you need to differentiate also. Okay, so first, so you need to differentiate this part by part. First, atas dan bawah. Okay. So when you differentiate 5t power of 4 minus 4t squared minus 1, then you will get 20t power of 3 minus 8t. And then when you differentiate this, 10 minus t minus 9t power of 3, you will get negative 1 minus 27t power of 2. Then you insert into the value of t. So actually ini pun salah t approaching 0 t approaching t approaching 1 value. So you masukkan nilai t is 1, then you get the answer. So ni first time you differentiate, you terus dapat value not 0. So that easy lah. Let's say if first time you get 0, 0, you need to again do another second differentiation. Okay, not second derivative, but second differentiation of the equation. Okay, second derivative lah juga sebenarnya. Until you not get 0. Okay, we get 1/2. Right, so this is L'Hopital's rules. Okay, maybe it can be asked in your test or final, right? Okay, so this is some example. You need to evaluate the limit by using L'Hopital's rule. So this is kind of example that you can try later on. Okay. Okay. So some example in question in final exam and so on. All right. So that is the indeterminate form with L'Hopital's rules by the find the limit and the limit function. Okay. All right. So that is another engineering application where you can use the differentiation. Okay. Now we go to another engineering application where we want to find the optimization application to optimization problem to find the maximum and minimum value. Okay, it also implement into a curve in the graph where a point that gradient is 0 is known as a stationary point or turning point. So when dy over dx is 0, whereas the slope of the gradient is 0, so it means that it is in the stationary point or in a turning point to another minimum or maximum value. So it's starting to be maximum and then going to be minimum and also maximum and minimum value. All right. So when dy dx or the gradient will be 0, it means it is in stationary point. So let's say at a equal to x1, so the function considered to be a maximum. So this x1, which is a, the function considered to be the maximum. And b, which is x2, the function is considered to be minimum. And c, which is x3, here flatten out point of inflection. So a, b, c, which is a, b, c is actually the stationary point. So the value of x1 here at a point is actually a maximum value. B point x value x2 is actually the minimum value, and x3 here actually the flatten out ataupun point of inflection. Okay, most likely kita guna sometimes in quality control and reliability. Right. So example for this application to find the maximum and minimum value. So consider the curve given by y equal to x squared minus 8x plus 18. Okay, kita ada this equation, kita ada this curve. Now when you need to find this curve, you need to differentiate to find the slope. So dy dx for this equation, you will get 2x minus 8. So dy dx equal to 2x minus 8. But dy dx is equal to 0, where you want to find is in stationary. That's why you will get 2x minus 8 equal to 0, because dy dx is equal to 0. Then you insert into the equation, you get x equal to 4, where 8 divided by 2. You get x value equal to 4. So now you have this x value. Okay. After you get this x value, apa maksud x value kat sini? Okay, the value x, because you want to find the stationary point, because you insert the dy over dx equal to 0. So this x value point for x, you can insert into the real equation, x squared minus 8x plus 18. Then you will get, you insert the x value, you will get the y value. So the coordinate of the stationary point where dy dx equal to 0, you will get point dia adalah 4, 2. Okay, 4 adalah x, 2 adalah nilai y. The coordinate of stationary point. Okay. Boleh Alright. So there are also many different definition. Okay, ada 3 definition. Okay, sebelum but it's more slightly theory lah. So for a function f defined on a set S of real number and the number C subset of S, so function C is the absolute maximum of f on S if fc is more and or equal to fx for all x in the subset of set S value. Kalau absolute minimum, yang mana dia punya function fc tu less or equal the value of fx. Okay, ni definition dia lah. To find absolute extremum adalah it can be absolute maximum or absolute minimum. Okay. Kalau nak cari local maximum, where the fc more or equal to fx for all x in some open interval containing c. Yang okay, ini more on definition lah. So kita tahu bahawa maximum and minimum value it can be found in curve. Okay. Dan nanti saya rasa dalam final akan ada soalan untuk you need to draw the curve by using the differentiation, where you need to find the minimum and maximum value. Okay, kemungkinan you akan perlu untuk cari, alright, the where is the minimum, maximum, and also then you need to draw a graph. Pernah kot belajar graph macam ni kan? Contoh, how you draw a graph. Okay, sketch a graph. Ataupun the definition 3, a number of C in the domain of function is f called a critical number of f if differentiation of fc equal to 0 or fc is undefined. So tadi kalau fc ni dia lebih besar daripada fx, value x dia, dia jadi local, ataupun dia untuk certain containing C lah yang ada C. Kalau absolute, dia for X subset of S tu. Alright. But if C, where F, bila kita dapat function ni, contoh y equal to X plus y equal to X squared plus 2, so then you get, bila you masukkan nilai, you dapat 0, so it means that called a critical number, ataupun dia called as a undefined. Okay. And then there are also some Fermat theorem where supposed to find FC at local extremum or local maximum or local minimum. Okay, kalau disebut extremum ni local minimum ataupun maximum, then C must be a critical number of F. Maksud dia C must be equal to a critical number. So how to find, let's say find the critical number for this equation. So you need to differentiate. So you will get this 6x for differentiation of this 2x squared, 2x cubed minus 3x squared minus 12x plus 5. You will get 6x squared minus 6x minus 12. Then you rearrange equation ni, then you dapat the nilai value of x equal to 2 and x equal to -1. Okay, to find the value of x when here equal to 0, then you can find. So the f has two critical number where x equal to -1 and x equal to 2. Ni untuk Fermat theorem. Ada satu lagi, increasing and decreasing function. So banyak sangat teori differentiable function over the interval AB. So if the function fx is said to be strictly increasing over AB when fx more than 0, f prime x more than 0. Kalau function fx ni said to be decreasing over point AB, AB ni adalah x, y. If f prime x less than 0. So dia decreasing kalau dia punya differentiation value dia less than 0, and differentiation of function to more than 0, it will be increasing. Okay. Suppose that f is continuous on the interval of AB and C is critical number lah. Okay. Okay, still lagi dalam teori. So selalu kita guna untuk second derivative is d2y over dx squared is actually the second derivative of the first function tu. Okay, where you can also find the local maximum and local minimum where the where the differentiation more than 0 for all x subset of a, c, and differentiation of function x less than 0 for all x subset of cb, where actually is increasing to decreasing at c, then the fc is a local maximum. Okay, ni very theoretical So kita tengok contoh kalau kita nak dapat nilai maksimum ataupun nilai minimum. So let's say if y equal to x squared, so dy over dx equal to 2x. Then kita differentiate sekali lagi, second derivative, kita akan dapat d2y over dx squared equal to 2. So to determine the max and minimum of curve f at the turning point, so kita guna dy over dx equal to 0, which is stationary point kan. Okay, when dy over dx equal to 0, So we need to follow the rules, which is y maximum bila mana the second derivative is negative. Tapi y is minimum bila mana second derivative value is positive. And the inflection ataupun flatten point tadi, inflection point tu when y the second derivative tu equal to 0. So actually dia go back to this graph, right? And the inflection is actually 0. So here, when let's say dia cakap kat sini, maximum adalah the negative, when you second derivative dia adalah negative value, and bila y is minimum bila mana dia punya dy dx second derivative tu adalah positif. Okay, y value. Okay, if y is max, so dy dx akan dapat negatif. Okay, sama juga untuk concavity theorem 1. If second derivative exists on the interval I, so second derivative more than 0, so dia akan concave up. Tapi kalau second derivative less than 0, then the graph of f is concave down. Rasanya ada satu soalan untuk final later about this, to draw the graph lah, whether it is concave ataupun concave up ataupun concave down. And also you need to find, mungkin you kena buat table. Okay, buat table, letak macam ni, macam ni, macam ni kan. Then you come out dengan graph tu ada concave. Pernah belajar kan masa metrik ataupun masa STP kan. Dia ada graph, apa nama, table, you cari nilai. So where actually you can find macam ni lah nilai you. Contoh. Alright. Okay. Maybe one question on that. So your test 2 and also your final, including the include the differentiation lah. Okay, ni yang dikatakan to find the concave or concave the up ataupun concave down. Tapi ni untuk second derivative. Ada yang sebelum ni kalau kita buat first derivative, kita pun boleh imply dia sama ada dia ni contoh second derivative lah, to find the turning point kan. Let's say example, find the turning point for y x power 3 x power of 3 divided by 3 minus x power of 2 divided by 2 minus 2x plus c. So when you do this, you find for dy dx equal to 0, but you need to differentiate first lah. So you will get here, right, first derivative lah. So when then second derivative, so ini example Then when you do the first derivative, you will get x squared minus x minus 2. Then you do another second derivative, you will get 2x minus 1. After that, when dy dx, you masukkan dalam first derivative here, you will get value of x plus 1. You simplify this equation, pecah apa nama, you ni buat apa nama untuk find the nilai x, you will get x equal to -1, x equal to 2. Okay, so when you use second derivative, okay, second derivative, you will get the value is 2x minus 1, betul ni 2x minus 1. So you masukkan nilai x yang you dapat dekat first derivative, you will get maximum value which is negative. Okay, kalau negatif dia adalah maksimum, tapi kalau masukkan nilai dia dapat positif, you akan jadi minimum. So this is how you solve apa nama turning point by using the second derivative equation. Okay, boleh sebab ada juga soalan, okay, to find the you need to draw the graph. Okay, you need to draw the graph. Okay, okay. So let's say kalau kita nak carilah graph tu kan, untuk nilai kat atas ni lah contoh. Saya ambil contoh lain. Ini contoh bila you nak cari find turning point for this line, for this equation by using second derivative. So first derivative, dan you cari dia punya nilai x by using dy dx equal to 0, okay, for stationary point. Then you have nilai x. The nilai x masuk dalam second derivative to find the value of maximum and minimum. Okay, pergi atas sekejap Contoh kalau ini critical number, okay, tak sesuai, tak apalah, equation ni lah So let's say when you get this equation, then you need to find the f prime, okay. Right, ataupun you dapat dy dx, you need to find the dy dx kan. Then you need to do some tables, contoh-contoh some table. So let's say when the value of x, contohlah macam tadi you dapat when the value of x is -1. So when value of x is 2 maybe, contoh macam itulah. So ni value of x, ni sin of fx, ataupun ni slope of graph. So maybe you dapat kat sini negatif apa nama 0, negatif 0 ke, contoh you dapat graph macam ni kan. Ada graph satu lagi sini contoh. So then you need to plot the graph by using the slope that you find here. So maybe there will be one question like that. Try to find. Try to do example. Okay. Which is you need to find this by using this application to find the slope of the graph. Okay. Boleh buat example kalau nak terang dalam ni agak susah juga dengan tak ada whiteboard ni. Okay. Alright. So that is example. So this second derivative example is where you want to find the minimum and also maximum value. Okay. Alright. For this is value for y, bukan value of x, because you dapat x. This is value to find the value of d2y over dx2. Okay. So y is maximum and y is minimum when you get the negative value is maximum and minimum is positive. Okay. Second example, which is you need to find the second derivative to find the local extrema, whether it's minimum or x maximum. So given question here, fx equal to x power 4 minus 8x squared plus 10. So when you first do the first derivative, you will get this equation. Then you simplify this equation. Then again you simplify, you will get to find the x value, which is x equal to 2 and x equal to negative 2. Then this is the critical number. Okay. And x equal to 0. There are 3 critical number. Okay. So we can test this using the second derivative. So you buat lagi satu derivative equation ni. So you akan dapat 16x squared minus 16. Then here 12x squared minus 16. Then when f is 0, bila critical number x equal to 0 here, so you akan dapat masuk 0, you dapat negative 16. Negative 16 adalah less than 0. So less than 0 adalah maksud dia apa? It is maximum. So when f prime x value adalah 2, you dapat 32. So it is more than 0. When you insert it also second derivative negative 2, x equal to negative 2, you get also 32, which is more than 0. So you have f second derivative 0 is local maxima because it is negative 16. And f second derivative for 2 and negative 2, you get they are local minima because you have 2 critical number, where these 2 critical number give you the minimum value because it is more than 0, and f second derivative 0 is negative value, it give you maximum. So this is how you can find the local minimum and local maximum, which is local extremum. Okay, this is some example. Alright. So there are also many examples. Okay. When you deal with sin x, there will be quite difficult when we deal with 0 and 2 pi and so on. Okay, contoh soalan-soalan final exam. Alright. I think okay, ini sama. I think that is the last slide. Then most likely I would like to you to look into how to draw a graph. Yang macam mana saya cakap tadi lah. How to draw a graph by given equation. Then you need to find the value of x. Then you need to find the sign of x value too, and also the slope, whether it is maximum or boleh. Alright. So that may be in your test or in your final. Okay, because you need to, there will be one question maybe in test, draw the sketch the graph from the let's say from this equation, then you need to differentiate, then find the value of x, and then find whether the x value give whether it is maximum or minimum to draw the graph. Okay, maybe you can find some example by your own. Okay, you can do that one. Okay, I think that will be the last slide. Yeah, for application. So in application, we use differentiation more on tangent, normal line, and also to find more like in L'Hopital's rule, which for limits. Okay, and also to find the maximum and minimum value for the optimization problem. Okay, optimization problem. So most likely kita guna yang itulah So dalam exam ataupun test akan tanya tentang draw a maximum and draw a sketch or graph lah. Okay, from the differentiation that you have. Okay, I think that will be the last class and also the last slide for today.